Hi everyone, welcome back to Smart Architectural Programming, your go-to channel for mastering Java and software development fundamentals. In this video, we're diving into a powerful yet often misunderstood keyword in Java, instanceof. This video is part of our series accompanying the book Introduction to Java, so make sure you follow along in the book as we explore real-world use cases, pitfalls, and best practices. So, when we're trying to understand the keyword instance of, we need to first understand what is the instance of keyword. That's the most important concept to this, right? So in Java, the instance of keyword is used to test whether an object is an instance of a specific class or a subclass. It returns a boolean true if the object is an instance and false otherwise. So let me put it this way. When you create an object from a class, right? That class is the blueprint and the object is the house itself, right? That's the concept that we discussed when we were going over class and objects, right? So when an object is built off a blueprint of a certain class, you can check that through the instance of keyword. As you can see in the screen here, the code that we see here, let me get my pen. So the code that you see here, this particular code is basically incredibly useful when working with polymorphism and dynamic types. Think of instance of as a safe way to check an object's type before performing a type-specific operation, as you can see here. So we're checking whether a particular object is a string or not, right? So the text here is being tested off is whether it is an instance of string or not. That's the basic core question here. So based on that, let's look at a few practical examples. And say we have an animal class or a dog and a dog subclass, and this goes back to the first thing that I was talking about with classes and their blueprints. That particular aspect of instance of gets covered here in our understanding. So we have a class called animal, right, which is a blueprint for a class called dog, which extends from the class called animal, right? And what happens is when we create a new dog instance, when we check is it an instance of dog, obviously because this was created from the dog class, it's gonna say yes, and that's what we can see here. And then we see if it's an instance of the animal class, right, which is the one that is over here. That's also true, because let's put it this way: if the animal class defined a certain aspect to it, to a blueprint, right? Let's say it's a two-dimensional home. The dog class just takes that blueprint and adds landscaping designs on top of that, blueprints on top of that. So if we test something and say, hey, is this part of the animal class, which is the two-story home? Then yes, it is. And is it part of the dog plan, which is basically the landscaping plans onto the two-story home? Yes, it is. And then we check, is it an instance of an object, right? It's definitely an object, right? So it's true as well. So that is where instance of objects are important. As you can see, we declared as type of animal, but it actually references to the dog object. Instance of tells us that A is a dog, an animal, and an object. That makes it great for inspecting objects when you're dealing with polymorphic code especially. So based on that understanding, let's get an understanding of how polymorphism and instances of relate to each other. So what is polymorphism and instance of together? When working with polymorphism, you might not know the exact type of object at compile time. This is where instance of really shines. As you can see in the code here, we're checking if the animal is really a dog before we downcast. Without this check, we risk a runtime error that would cause problems. So we are checking here if animal is really a dog before we downcast. So here, if you can see, if animal is instance of dog, then dog, 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 animal, right? We check downcasting that. So if we downcast without that check, we're going to create runtime errors and problems in our code that we probably want to avoid. And if you're not familiar with polymorphism, that's something that we might cover later in our channel. So make sure to let us know if you're interested in polymorphism in Java and understanding how it relates to object-oriented programming in Java. So let us know in the comments below if you're interested in that topic. So now that we understand that, let's move into avoiding class cast exception errors that happen with instance of keyword when we use it incorrectly. So when you try to cast an object to an incorrect type, which results in basically the class cast exception error. As you can see here, as you can see on the screen right now, we have a new animal, and then we then we throw basically cast an object to an incorrect type, which causes it to throw class exception error. So this A is being cast as dog, right, as you can see here, but A has been set up as an animal class object. So that is going to it's an animal object, right? So that casting is going to throw a class cast exception. Similarly, if you use instanceof to check first, we can avoid this error. So if A is instance of dog, dog D equals to casting dog A, right? That would make sure that if the instance of A is dog, only then cast it as dog further down in the code. So that is basically what a class cast exception error is and how to avoid it. So what are some of the best practices of using instanceof? Usually overusing this can lead to design smells and problems. So there's certain practices that you need to keep in mind when you use the instanceof keyword. Number one, favor polymorphism over instanceof. Basically what happens here is if you find yourself checking types too often, it may be better to just use abstract methods or interfaces to do that. That's going to waste a lot of your time. Using pattern matching from Java 16. Java now supports pattern matching for instanceof, which simplifies the syntax for you to do pattern. Supports pattern matching for instanceof, which simplifies the syntax for using instanceof in Java 16 plus versions, basically. After that, basically remember number 4, on number 3. We need to avoid using instanceof with unrelated types. It will always return a false value, so don't need to waste your time on that. Avoid in equals methods. Use get class instead of compare exact types, basically. And use sparingly in large inheritance trees. Too much of instanceof logic can make your code hard to maintain and hard to look at. To wrap up, instanceof is a powerful tool for safe type checking, especially in polymorphic systems, but like any tool, it works best when used thoughtfully. A quick summary of what we covered in this particular video. We learned how to use instanceof to safely check for object types. We understood how combining with using instanceof with before downcasting, we can avoid class cast exception errors. We also learned how to use polymorphism and interfaces to design cleaner code, and we also looked at exploring pattern matching for modern Java syntax in context of instanceof. If you enjoyed this video and found it helpful, don't forget to like, subscribe, and click the bell icon so you don't miss the next chapter from our next video from our Introduction to Java series. And let us know in the comments what's the one thing about instanceof you learned today. And with that, thanks for watching Smart Architectural Programming, where we bring software to structure.